Hey everyone, and welcome back to our series on the incredible achievements of quantum physics. Today we're talking about something we all use every single day, something that literally runs our world, time. But not just any time, quantum time. See, our entire modern civilization, from the phone in your hand to the global economy, depends on keeping time with unimaginable precision. And that precision comes from the weird world of quantum mechanics. It all started back in 1955, when scientists figured out a revolutionary way to measure time. They discovered that atoms, the tiny building blocks of everything, can act like perfect tiny clocks. How? Well, in the quantum realm, atoms don't just sit still. They constantly oscillate, or jump, between different energy levels. And they do this with a regularity that is just mind-bogglingly consistent. Think of it like a pendulum that never, ever slows down. By measuring these tiny regular jumps, scientists built the very first atomic clock. This clock was so accurate, it would lose less than a single second over millions of years. Compare that to your wristwatch. This incredible invention wasn't just a cool science experiment. It fundamentally changed the world by making one of today's most essential technologies possible, the Global Positioning System, or GPS. So, how does it work? High above us, a network of satellites is circling the Earth. Each of these satellites has multiple atomic clocks on board. And what do they do all day? They just shout the time over and over again. They broadcast a continuous stream of super precise time signals down to Earth. When you pull out your phone to find the nearest coffee shop, your device is actually listening for these signals from multiple satellites at once. The magic happens next. Your phone measures the tiny differences in when each signal arrives. We're talking differences of billionths of a second. By comparing these minuscule time gaps, your phone can triangulate its exact position on the planet with remarkable accuracy. It's a symphony of timing, all happening in the blink of an eye. Now, imagine a world without these quantum clocks. What would happen? For starters, your GPS would become useless almost immediately. Without the constant correction from atomic clocks, GPS calculations would drift by several kilometers every single day. Your navigation app would send you into a lake instead of to the library. But the chaos would go far beyond just getting lost. Air traffic control relies on GPS to manage thousands of planes in the sky. Without it, the risk of collision would skyrocket, and global air travel would grind to a halt. The entire global logistics network, the system that gets packages and goods delivered to your door, would collapse. It gets even bigger. Think about the global financial markets. High-frequency trading depends on synchronizing transactions down to the microsecond. Without atomic clocks, financial systems would lose sync, causing absolute chaos in the world economy. Even our power grids, which need to be perfectly synchronized to prevent blackouts, would become unstable. So, you see, modern life is built on a foundation of quantum timekeeping. It's this invisible, silent technology that keeps our interconnected world running smoothly. You don't see atomic clocks. Probably don't think about them. But every time you use a map, stream a movie, make a call, or even swipe your credit card, you are relying on a principle born from quantum physics. We've literally engineered time itself. It's a powerful reminder that some of the biggest technologies shaping our lives are hidden in plain sight. It's born from our quest to understand the universe at its most fundamental level. The world doesn't just run on time, it runs on quantum time. Thanks so much for watching this episode. If you found this as fascinating as I do, make sure to hit that like button.